All right, so domain of a function. What's domain refer to? All possible x values. All right, what does range refer to? Very good. All possible y values. Okay, domain is the inputs. What can I put into the problem? Range is the output. What can I get out of the problem when I put the certain things that I can put in? All right, there are different forms of equations. There's implicit form. Implicit form of a function. Implicit form is where x's and y's are like all mixed up. We've had implicit equations like x squared plus y squared equals 6. That is an implicit equation. You actually worked with those in Algebra 2 and in pre-calculus. That would be an equation of a circle. Circles, ellipses, hyperbolas are all implicit equations, where the standard form, the normal way to look at it, has x and y all mixed up. Even standard form of linear equations is an implicit form, okay? It's just a vocabulary word. Okay, but why is it important? If they refer to implicit form, you need to know what it means. All it means is it's a different order of writing the equations. It's not y equals. Okay? And then there is function notation. Function notation means instead of writing y equals x minus 3, we would write f of x equals x minus 3. These are the same thing. We are just replacing with y with f of x. And this is called function notation right here. And that is a common way that we write functions because it makes things like operations with functions easier to deal with. So operations with functions, or what I like to call composite functions. Okay, we're just going to look at some examples here. Composite functions and the directions that would go with your homework. They are going to say evaluate, if possible, the function at the given values of the independent variable. Half the difficulty in calculus or any math is deciphering the instructions. This is where you must know your vocabulary, okay? Evaluate. Work it out. If possible, meaning maybe you can't always do it, the function at the given values of the independent variable. The independent variable is always x. X is the independent variable. So how would you refer to y then? The dependent. Why? Because y depends on what x is. All right, so then our problem looks like this. Let's say I have f of x equals the cosine, let's see. Yeah, f of x equals the cosine of 4x. And I would like to find part A, f of pi over 2. Part B, f of pi over 3. And part C, f of, I don't know, negative pi. This is saying plug pi over 2 in for x. So f of pi over 2 would be the cosine of 4 times pi over 2. Now, question, how do you work that out? What is the first operation you should do there? Is it cosine or times? It's the multiply. Because it's the cosine of this whole thing. Here's something you need to be aware of. They did the same thing in your pre-calc book. They do not put parentheses around the 4x, even though they mean the cosine of 4x. That's what they mean. It's just not done. All right, so first I multiply. So I'm really finding the cosine of what? 2 pi. Okay? Some of you in your calc book, some of you have the luxury of having this little blue page in the front. It's a beautiful page. It has a lot of information. If you turn it, it has a little unit circle. Otherwise, you should find your unit circle from pre-calc and bring it every day. You never know when you're going to need it, and we use it all year. Okay, I'd like exact values, not decimals. Some of you, I mean, your calculator can give it to you too. You just have to make sure you're in radians because this is radians. So the cosine of 2 pi is going to be what? Nope, no decimals. You're not in radians. Use your unit circle. 2 pi is the same as what angle? 0? Not in degrees. Okay, here's the deal. Calculus hates degrees. Never, ever in degrees in calculus. Ever. Always radians. So if you want to evaluate any trig functions, your calculator is in radian mode. I recommend you learn how to use the unit circle. Okay? Unit circle. It's right here. Okay? 2 pi is right there. Remember each of these ordered pairs? They give you both the cosine of the sine of that angle. The x value is the cosine, the y value is the sine. So 2 pi is right here. The cosine would be 1. Every one of these ordered pairs gives you both the sine and the cosine of whatever angle is right there on your unit circle. If you want to find the tangent, you take the y value divided by the x value. And then if you have the sine, cosine, and tangent, then to find the other three, you just take the reciprocals. Okay? You learned that in pre-calc. Okay. So the cosine of 2 pi is 1. So now I need to find f of pi over 3. What? Just 1. All right, so now I want to find the cosine of 4 times pi over 3, which is 4 pi over 3. 4 times pi over 3 is 4 pi over 3. Okay, so 4 pi over 3 on my unit circle, where's that? Let's see, it's right down here. So what is the cosine of that? Negative 1/2. Okay, f of negative pi. So the cosine of negative 4 pi. Where's negative 4 pi? It's right at the 0. Here's negative 2 pi. Here's 2 pi. Negative 2 pi is just around backwards. So negative 4 pi is still there. What's the cosine of negative 4 pi? It's still 1. All right, so that was a really easy one. So some of you are thinking, oh, no, that's not. All right, let's see. Let's take a look at another one. That is P1, 2, 3. All right, so let's say I now want to find for f of x equals x squared minus x. I guess you might want to see that. And I want to find these three things. I want to find f of 2b. I want to find f of x plus delta x minus f of x all over delta x. So this is part A and B. So same thing, same directions as before. I want to find those two things. Okay, so f of 2b, what is this telling me to do? To put 2b in for x. Which x do I put it in for? Both of them, every one of them. So f of 2b would be equal to 2b, watch, be careful, watch up here. Some of you just, you miss the little things and therefore you make big mistakes. You're plugging 2b in for x, in parentheses, just like with the origin testing, minus 2b. So now I need to simplify this. What is 2b squared? 4b squared minus 2b. Okay? When you square 2b, you're taking 2b times 2b. 2 times 2 is 4, b times b is b squared. So this is the answer to part A. Part B, I cannot stress how very important it is for you to know how to do this. It looks horrible. It is not that bad. Okay? You will see me do this about 35 times. Jared. I don't know, but they're calling you out of class. I think that's just a bad idea.
Am I leaving now?
It says at once. Okay, so first of all, it can be confusing because you have x's in your function and you're replacing it with x's. But this is actually very simple. This is what you need to do with this type of thing. You need to think of it as one part, part 2, and part 3. So in order to evaluate or work out this entire thing, you want to think of this in 3 parts. So the first part is this. So first of all, we're going to find this. So f of x plus delta x. Sometimes the big thing is overwhelming. So we're going to take it one part at a time, and we're going to do the hardest part first, which is that part. And it's not that hard. What are we replacing x with to find this? We're replacing it with x plus delta x. We are replacing just like here. This is f of 2b. What are we replacing the variables up here with? 2b. This is f of this. What are we replacing the variables with? X plus delta x. So each of these is going to get replaced with x plus delta x plus x plus delta x. So we take the original function and we replace each variable with whatever's in parentheses. Okay, now, we're not done with this because we need to simplify it. So what should we do here?
Can you just take out an x plus delta x from each one?
Oh, that's very interesting. How would that benefit us? Now, well, it is already all pretty factored out. Okay, when you say factor, what's the difference between, what is factoring? What does factoring mean? You say factoring like you know what it means. What does it mean to factor? Factoring is multiplying?
No, yeah,
What? Louder so everyone can hear.
Taking the x or the equation and putting it back in parentheses?
Yes, factoring is putting parentheses back in. Doesn't this already have parentheses?
Yeah.
So don't refer to it as factoring. Okay? What do we need to do to this? We need to simplify it. What are the 2 steps in simplifying from algebra? Get rid of the parentheses and then add like terms. Those are the 2 steps in simplifying. When you're evaluating, you're trying to simplify. So we need to get rid of parentheses. What do I need to do here to get rid of parentheses? Foil. Foil, that is so important. Write that down. You have to foil. Some people just want to go x squared plus x delta x squared. Now, here's what you need to realize. Delta x is a variable. A variable. The delta and the x can't be separated. I could call it a heart if I wanted to. I could put, whatever, a happy face there. That is a single variable like b or q or n. So don't think it's different. So if I FOIL this, I'm taking x plus delta x times x plus delta x. And then I can't forget this part. I need you to focus and pay attention to this right now.